Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/41 for the session May June 24. And we are going to solve question number 6, which says a particle moves in a straight line starting from a point O. The velocity of the particle at time t second after leaving O is v meter per second. It is given that v is equal to k t raised to half minus 2t minus 8, where k is a positive constant. The maximum velocity of the particle is 4.5 meter per second. Question number A says, show that k is equal to 10. Well, first of all, we will find out the concept we should apply for solving such question. If we observe the question, look at this. In the question, actually, simultaneously two values are missing. One is the missing value of k as well as missing value of t. So one thing is very sure, at one step we cannot solve this question. If there are two different values missing, that means we will have to form two simultaneous equations. So let's start the first equation. How can we form the first equation? It is written that maximum velocity, look at this is the clue word, maximum velocity is 4.5 meter per second, and we know maximum velocity means actually derivative of velocity, that is acceleration. So maximum velocity is 4.5 means derivative is 0. So let's start with our v. Velocity is given. What is the velocity given? V is equal to kt. We can arrange in ascending order or descending order. Minus 2t plus k t raised to half, let me write a little bit upward, t raised to half minus 8. Well, so we will find the derivative of this, which will be 0. dv over dt means acceleration, which is 0. So dv over dt is going to be, here it is going to be minus 2 because power is 1. So minus 2 plus, as here power is half, so it will be k over 2. And we know if we subtract 1 from half, it is negative half, that means 2 square root over t. Okay, minus derivative of constant number is 0. So this is our acceleration. Okay, hence acceleration is going to be negative 2 plus k 2 raised to t. But for maximum velocity, let's not write acceleration, let it be dv over dt. Okay, we will just leave this as derivative of velocity. So what will it be? It is dv over dt. Hence dv over dt. Now we will write the sentence for maximum velocity. Maximum velocity maximum velocity for maximum velocity, dv over dt is 0. Remember, when for maximum and minimum velocity always derivative is 0. dv over dt is equal to 0. That means minus 2 plus k over 2 square root over t is equal to 0. So ultimately what is it going to be? It is going to be, or k over 2 square root over t is equal to 2. Means we are supposed to find t. We will isolate t on the left side. So 2 square root over t into 2 is k equal to k equal to k. Or if we isolate t as subject, t is going to be, or square root over t is actually k over 4. Hence our t is going to be, if we square on both sides, it is k square over 16. This may be an equation. Initially we have clarified that we will have to form two simultaneous equations. So let's solve the next, let's form the next equation. What is the next equation? They have told that velocity is equal to, maximum velocity is how much? 4.5. So we will write, let me write just beside this. So v is equal to 4.5, maximum velocity is 4.5, and v, the expression for v is what? Negative 2t plus k, we can write it as square root over t, square root over t minus 8, minus 8 is equal to 4.5, 4.5, it is 4.5. Well, now as we have already obtained the value of t, how much is the value of t? Value of t is k square over 16. So we will substitute just over here, minus 2, and t is just k square over 16 plus square root over t k, then square root over t was how much? Square root over t was this k over 4. So square root over t is k over 4 into k over 4, k over 4 minus 8 and minus 4.5, it is going to be actually 12.5, 12.5 equal to 0, equal to 0, equal to 0. Well, then how can we simplify this? Here 16 is the LCM. So if we multiply every quantity by 16, it is going to be minus 2k squared plus k squared minus 16 into 12.5 is 200. 200, because 8 into 12.5 is 100. So it is going to 200 equal to, right side is 0. Or minus 2k square and k square, that is, it is not simple k square, it should be actually 4k square, because 4 fours are 16. If we multiply by 16, it is going to be 4k square. So let me write 4k square. Now if we simplify 4 square minus 2k square, that is 2k squared. So 2k squared minus 200 over 16 equal to 0. That is 2k squared minus 200 is equal to 0. If we simplify more, it is going to be actually k is equal to, k is equal to square root over 200 over 2. So 200 over 2 means 100. Square root of 100 means 10. Hence k is equal to 10. We are ignoring negative value because they have told that k is a positive instant constant. It is written that k is a positive constant. So we are ignoring negative value. That means our k is equal to 10. And they have told us to show this. Let us write here showed. Okay, so this is how we will solve this part of the solution. So first concept is, what we have applied is, we will have to find for maximum velocity, always the derivative is 0 or acceleration is 0. So using the concept of maximum velocity or derivative 0, we have obtained this t, the value of t, as I have told, simultaneously there are two values missing, so in one step we cannot solve the whole solution. That's why we took two steps. And then maximum for velocity is given 4.5 meter per second. Applying the value of t, we have got that k is equal to 10. Let's move on to the immediate next question. The next question says, it may be on the next page. Yes, the next question says that verify that v is equal to 0 when t equal to 1 and t equal to 16. One of the very easiest questions actually. So it is written v equal to, our v equal to what? V was, if we go back to the previous page, v is nothing but this. V is this, minus 2t minus 2t, we are at this page. So v is equal to, let me erase this. Our expression was v is equal to, v is equal to what? Minus 2t plus 10 k square root over t, that means 10, the value of k is 10, 10 square root over t minus 8. Well, they have told that v is equal to 0, that means this portion is equal to 0. We can write it again. V is equal to 0 when 0 when minus 2t plus 10 square root over t minus 8 is equal to 0. Now we can simplify this, dividing every quantity by negative 2, it is going to be t, then minus 5 square root over t minus 4 equal to 0. If we expand this, what is it going to be? T minus 4 square root over t minus square root over t minus 4 equal to 0. If we simplify more, that means if we factorize this, it is going to be, or t minus, not t, square root over t is common, so square root over t minus 4, the first factor, and the second factor is going to be square root over t minus square root over t square root over t minus 1 equal to 0. Hence our t is going to be what? Square root over t is 4, so t is equal to 4 square means 16. Hence our t is going to be 1 as well as 16, because 1 square means 1. So they have told us to show this. We will just write showed. This is one of the simplest of all solution. Well, let's move on to question number C. Question number C says that find the distance traveled by the particle in the first 16 seconds. Okay, for solving such question, first of all, we will have to sketch the figure. Look, the original, let me change the ink. The original expression for velocity was this. Okay, this one. Now let us draw the velocity time graph. After zooming it in, yes, let me draw the figure over here. It is t meter per second, I mean t second, t second, t second is the horizontal axis, here 0, and vertical axis is v meter per second, v meter per second, v meter per second. Let me write just below, sorry, above that, v meter per second. Okay, now if we look at the expression over here, as this is actually a negative quadratic graph, and negative quadratic graph always starts from the third quadrant. Well, for third quadrant, look at this. When t is 0, the velocity was negative 8. So let's write here negative 8. It is negative 8. Well, this is negative 8. Then curve starts from here. After that, we have proven one more value, that when at first second or at 1 second and 16 second, actually the particle was at rest, because v was 0 at when time was 1 second and 16 second. So let it be 1 second over here, 1 second, that is time is 1 second, this is 1 second and this is 16 second. Okay, so let it be written 1 over here, 1 over here and 16 over here. And the curve, we have already come to know that curve start from here, that is like this. At 1 second it is at 0, means rest, then it went up, then went down again. Well, something like this. So this is what the curve. Now look at this, there are two parts of the same curve. This portion, look, this portion of the curve is lying just under the x-axis. That means it will produce negative distance, negative value if we integrate this. And this portion is above the x-axis, so it will itself produce the positive value. Well, and the basic concept we know, for finding the distance we just integrate the velocity. So our v is what? Let us write v. v is equal to negative 2t, negative 2t plus 10 square root over t minus 8. Well, then we know, for finding the distance or displacement, we just integrate velocity. So let us integrate velocity. It is just integration of velocity for the first part. It is until from 0 until, let me write the integration symbol. Okay, for the first phase, look at this, first phase was from 0 until, from 0 second until 1 second. So this is 0 until 1 second v dt. We are integrating the velocity to find the distance. So how can we find the distance? If we integrate velocity, we will find the distance. So it is going to be negative 2, and you know the power of t is 1. So if we add up 1, it is going to be 2, which will divide this, then t square, and our time span is what? 0 until 1 second, minus, for the second quantity here, square root, I mean power is half, so it will be divided by 10 divided by half. Well, after that, our square root, that means here power is half, if we add up half plus 1, it is going to be 3 over 2. So it is going to be 3 over 2, which should be written as 3 over 2 will be 2 over 3. Well, then, sorry, I made a mistake. There should not be any 2 over here, because we will just write the added power. We will divide by the added power. So power of t is going to be 2 over 3. If we divide, it is going to be power of t will be 3 over 2. If we divide it by 10, it is going to be 2 over 3. Then we have already seen that power of t is going to be 3 over 2. 3 over 2, and the time span is 0 until 1, minus, it is going to be minus 8, and for constant number, it is nothing but t, 0 until 1 second. So let us do this calculation. It is going to be, or we can symbolize this at S1, I mean first displacement, or displacement in the first phase. It is going to be -1, and t square means actually it's 1, so -1 minus, it is going to be 20, and 20 over 3 minus 8. 8 into 1 is actually 8. Look at this. 1 minus 0 means 1, so 8 ones are 8. Initially, we have already come to know that this portion, for the portion below x-axis, will produce negative value, but displacement is always positive. That's why we will find, I mean our distance will always be positive, so we will use modulus symbol over here. Let us use the modulus symbol. That means we are supposed to pick up the positive value, ignoring negative value, so it is positive. Okay, so what is it going to show now? And this before 10, this symbol is not negative at all, this is positive actually, so this is also positive. Well, so what will we get? 1 plus 8 means 9, so it is going to be 27. Negative 27 plus 20, that is negative 7. Modulus of, modulus, let me erase this. It should be written, it should be written with a different ink, that is red ink. Hence our S1, S1 is going to be, hence S1 means displacement in the first 1 second is actually what, 7 over 3 meter. This is the first part of the displacement. Now for, look at this from the graph, what did we learn? That this is the graph. So for the second part is actually this portion. Okay, this portion is lying above x-axis, so definitely this will produce the positive value. So let us write the S2. Okay, our S2 is going to be, let me write just over here, S2. S2 is S2. Already we have integrated, we will just write the values over here. Integration was what? This is negative 2 over 2 means 1, so t square, it is negative t square, t square. No, I will have to zoom it out. Yes, so it is going to be, yes, S2. S2 is equal to negative t square. We are just copying from the previous integration. And time span is now, look at this, from what time to what? It was from 1 until here. Look at this, from 1 second until 16 second. So just there will be the difference in the time span, 1 until 16 second, then plus 10 into 10, not 10, it was 20. Look at this, what is it? It is 20 over 3 here. Look here, it is 20 over 20 over 3. So we will write here 20 over 3. It is 20 over 3. So 20 over 3 t raised to 3 over 3 over 2, and time span is how much? 1 until 16 second. 1 until 16 second minus 8t. 8 minus 8t. So as there is a shortage of space, let me zoom it out. T, it is going to be t. Okay. and I will have to erase some of the parts here. Well, then it is going to be t, and time span is 1 until 16. 1 until 16. So let us calculate now. Or S2 is equal to S2, or S2 is equal to negative t square. Look at this, 16 square. 16 square means 256 minus 1. 1 square means 1. So 256 minus 1 is 255. Negative 255. Negative 255 plus 20 over 3, and 16 raised to 3 over 2 means actually 64. So 20 over 3 into 64 minus 1, whatever is the power, it is 1. So 64 minus 1 is 63. Well, 63 minus 8 into 16 minus 1 means actually 15. It is going to be 15. Well, so if we calculate this, we are going to get S2 is equal to, it may be the last step for the second phase of the solution. So hence second displacement, or displacement in the second phase of time, is how much? It is going to be, so 3, no, not 3, there should not be any denominator. 3 to 63 is actually, if we divide 63 by 3 is 21. So negative 255 plus 21, 420 minus 120, it will produce, let me calculate this, it will produce nothing but 45. It is 45 meter. So in the first phase, we can see, in the first phase the distance traveled was 7 over 3 meter. Now we'll let hence total distance. Total distance is, in the second phase it is 45 meter. In the first phase it was 7 over 3 meter. Let me show you. It was in the first phase, S was what? This is the first phase. This is the first phase, the distance traveled in the first 1 second, and this is the distance travel in the next 15 seconds. Okay, that means from 1 second to 16 seconds. So total distance is going to be, if we add up, if we divide 7 by 3, it is going to be 1.3. So 1.3 plus, sorry, 2.3. 2.3 plus 45, that is 47.3 meters. So this is what the total distance we can show. So what did we learn from here? We know that simple concept for finding distance is actually nothing but integration of velocity. Integrating velocity, we can find the distance. But as the graph, according to the graph, some part of the, for first 1 second, the graph lies below the x-axis. That's why it produced negative value, which has been ignored, and we picked up only the positive value of s. After that, applying the same integrated part, look at this. This is our integrated part. Okay, the same integrated part has been written over here. If we integrate once, that is sufficient for us to be used. Look here, both the integrated parts are exactly same. This one, let me show with different ink. Yes, this is our integrated part. Okay, the same integration has been used over here, so you should not get confused. Where did we get this expression? It is actually from the first one. After that, we have just substituted the values as per the limit. So finally, what did we get? We got the total distance traveled is 47.3 meters. I think you have understood what I have explained so long. And thanks all for watching the video. And we will discuss the immediate next solution in the next video, inshallah. Fi amanillah. Before I leave, let me erase this unnecessary part. Yes, that is the total solution at a glance. So, fi amanillah.